Hi. All right, so it's been a really hectic week, I'm sure, for you guys, and hope everything's going well. I'm really looking to try to reconnect with the class now and get focused on finishing strong and finishing this project. So I have a bit of news for you. First up, the final test. I've gotten permission to remove that test from the evaluation. And the reason behind that is just to sort of reduce the stress. It's a very stressful time for a lot of the students. Reduce that stress, and also to make up some of the lost time that we've had. We can now put all of our effort towards the project because there's quite a bit of work to do with the project. All right, so for the project, it was worth 30% of the final mark. But now that gets bumped up. I think it's now 37 or 37.5% is what it'll be worth. And other assignments also will be reweighted as well to be worth a little bit more. So I'm planning to post several videos to basically try to walk you guys through some of the steps and point out some of the technology that you'll need to complete the Apple Watch project. And also assignments. I've been checking on D2L, and we have a few assignments that have recently come due. So if you haven't had a chance to get those in, please try to get those in as soon as possible so I can grade them and get them back to you. Okay, so I think what we'll do now is I'm going to switch over to Xcode, and we're going to go over the project, do a little bit of review with SwiftUI. And we can check out the repository. It's now set up and ready for us to begin work on. And for the project, the main two technologies we'll be focusing on are the SwiftUI and also SpriteKit. Okay. Hello. All right, so starting off with, let's just go through the project a little bit here. So I'm looking at the D2L shell, and a few things I've recently updated. You'll notice here I've added a project rubric, basically just showing the different tiers and what you need to do to achieve a certain grade. Let's see what else. Yeah, let's take a look at the rubric. Okay. So we've already been over the project overall in class, but there is also a document that goes over a few more details explaining the project. So I would recommend taking a quick look at that. All right, for the rubric, so the level 1, the 6 out of 10, basically you have 3 objectives, whether it's, collect wood, go to the repair station, call for an escape. Okay, whatever the 3 objectives are, you have those in, and they all pretty much work. You finish one, you go to the next. You display on your UI that you have some step goals. You've taken the time to comment your code, and you've replaced basically there's really no assets in the repo. You've basically added the correct assets that I'm going to be posting on D2L into your build. So that would get you 6 out of 10. To get 8 out of 10, you need all of the same items, but in this case, we want to see no major bugs. So if I should be able to play through it a few times, it'll feel pretty solid. It doesn't mean I won't experience a bug, but overall, I should have a pretty good experience playing it. In addition, you also have to add the random event. So one example could be a bear starts chasing you. Now you have to walk a certain distance, to get away from the bear. And also another one that's pretty significant, the UI is displayed with SwiftUI, not SpriteKit. And we'll get to that in a minute here after we're done this. But right now in the repo, the UI is all displayed with SpriteKit. But obviously we're learning SwiftUI, so I want to at least do the UI components in terms of like how many steps you've gone, what your goal is. I want that to be rendered with SwiftUI. So that's your 8 out of 10. And then to get perfect, you would need to have really nice polished transitions between your objectives and I'm also asking for an additional random event. So that would bring it up to 2 random events, and then a nice transition between your objectives and a really high level of polish. All right. So let's go back here and, all right, Mac in cloud accounts. So I've given out, emailed everyone their Cloud Mac accounts. So please go in and make sure you can access your Cloud Macs. As well, the accounts that you have restrict you to 3 hours of access per day. So just be aware of that. Okay, so let's talk a little bit about the repository. So you guys have been taking a look at the repository that I had used last year for this project. And recently I've gone in and I started making a bunch of changes. And what I decided to do was I actually created a new repository for the 2020 version of the project. And the reason I did that is just simply that we're using the SwiftUI this year, and last year we weren't. So the changes were quite drastic, and I wanted to start with kind of a fresh, clean project. So I thought basically starting a new repo would be the best way. So let's open up the repository here. I've got my Xcode going. And if you had taken a look at the previous repository, you would have noticed there were quite a few more files. So here it's really quite small what we have. So basically we have our content view, and this is the main view that is loaded in SwiftUI when we run our watch app. We have a class here called hosting controller. And this class here basically just it implements the WK hosting controller, basically inherits and implements that protocol. And what that does is that allows SwiftUI to be run as the main interface on the watch. All right. We also have a sprite kit view. So this was actually a little bit of work. If I look back here at the hosting controller, so this was the same as what we had for our Hangman assignment, where the WK hosting controller protocol, that allows us to run the SwiftUI as the main watch interface. The problem though is when you start using SwiftUI, WatchKit components don't necessarily work directly with SwiftUI view controllers. So when you look at the sprite kit view, what we've done here is we've implemented a protocol WK interface object representable. And by going through and implementing the protocol, which means we have these two functions, make WK interface object and update WK interface object, by going through and setting those up, now we're able to actually bring in the sprite kit view and render it inside SwiftUI as basically a Swift view. Okay, and then we also have walk scene. Now, in the previous repo, there were a whole bunch of scenes. I just kept just a simple one here. So this is the scene that we load when we come into when we first initialize the game. And basically it just shows a character walking, counting up to 30 steps, and there's a little bit of UI there. So that's pretty much all there is really in the repo. So it's a nice clean repo, and we can start building off of this. So I'm going to go ahead and fire up the project here. So it's going to build, and it'll run it on the simulator. So that's probably the one disappointing thing about now that we're working remote is I was looking forward to working with the pedometer data on the actual physical device, but of course we won't be able to do that. Okay, so we have the character basically as they move towards their objective. I'm interpolating their position across the screen, and you can see here the UI is counting up, so 16, 17, 18, it's going to count up to 30 steps. At that point in the final project, we would want to switch to another scene. unless it's the final scene, and then we would put up a view that would basically say you win. Okay, so that's all we've got right now. All right. So one of the reasons why I went with this architecture of integrating the SwiftUI was basically just because we've been learning it all semester. So even though the previous year project didn't use any SwiftUI, it only did SpriteKit, I kind of felt like that I didn't want to go that route because then that's sort of throwing away a lot of the work that we've done so far. So right now, when we run the game, though, we're not really seeing much SwiftUI, okay? In other words, the character, that's a SpriteKit node, and the two text elements, those are also SpriteKit nodes. So for example, if I were to go here, and in my walk scene, so this is inheriting from SpriteKit scene, you can see that I'm declaring my character, which is a SpriteKit node. And that's basically going to handle the rendering of the image and the animation. And then I also have my task text and my step text. And these are SpriteKit label nodes. So one of the tasks that we'll do for this project is we're going to basically remove these UI. Well, the character will remain. Anything that we're rendering kind of like a game, we will keep. But the UI labels, I'd like to use SwiftUI to render those instead of SpriteKit. All right, so let's just talk a little bit about what we need to do in terms of to make some changes and use the SwiftUI. I'm going to post some links in the video description. But basically, Swift uses a lot of these property wrappers. And so if you're not used to that, definitely want to go back and review some of this. Being able to use these property wrappers is pretty much key to being able to update data and display it inside a SwiftUI view. So let's just go over a couple of them here. The first one is the state property wrapper, and this is one of the links I'll show you. But basically, the state property wrapper is very simple. If you have a struct, and inside that struct you have a piece of data that you would like to basically observe when it changes, then you can use this property wrapper. And essentially what SwiftUI does is it allocates a special memory address so that when you pass this struct around, it doesn't lose track of that data. So this can be done, this state property wrapper, it can be used if you have a really simple piece of data. And it can only be used inside a struct. So an alternative to that, if you're using a class, which is usually probably more common for what we'll be doing in this project, we'll have a class that'll have some data and we'll be running, basically updating the state of the class as we go. In that situation, you're probably going to want to use this published property wrapper. So essentially you implement the observable object protocol, and I think all that means is it has to be a class. That's actually, I believe I read that. It has to be a class. Anyway, then you're going to mark any properties that you want to automatically update a SwiftUI view with @published. And then from there, you would use the observed object. So when you actually instantiate that class, you would mark it as an observed object. And that's basically hooking up the view to the actual update of the data, and then you'll be able to see your Swift view. It'll be redrawing itself whenever any changes to that data are made. So using those, you can pretty the state and then the observed object and published property wrappers. You can easily pretty much have your view be responsive, which is called responsive design. Have it be responsive to any changes in your data, which is a nice feature of SwiftUI. Okay, so let's just play around with the maybe use some of these property wrappers, and I can go in and maybe demonstrate removing one of the labels from the SpriteKit scene, and instead I'll render that using some of the skills that we've learned already in SwiftUI. So let's go back to Xcode here, and we'll go to the content view. So first up, we only have just the one sprite kit view there. And as we know, if we want to stack or lay out other view controllers, we're going to want to use one of the like VStack or HStack or ZStack layout systems. So in this case, I'm going to use a ZStack. So type in ZStack. And so in other words, we're basically using the painter's algorithm. We're going to stack items from back to front. So now I can go and I can create a new node here. So I will create a text hello. And let's just run this, and we should see hello centered in front of the character. There we go. All right. So perfect. That's great. So really, all we now need to do is just create some data, add our properties to it, and then modify that data, somewhere in our code. And if we've hooked it up properly, we will see our UI update. So what I will do now is I'm going to create a new class, which is going to represent the data that I want to have. So I'll go into my project here, and I'm going to add a new file, and it's going to be, of course, a Swift file. And I will call this file UI stats. I'll create it. Okay, and so I want to have a class UI stats, and this class is going to have, let's just create one property, so at published, and we'll call it var steps, or actually we'll call it var objective. All right. Okay, so I've labeled it as published, so that means it will be, it'll basically send out signals whenever it's changed. And I should also say that this implements the observable object protocol. All right. Okay, so I've got that done. And now if I go back to my content view, inside my content view, I can go ahead and create this class here. So I can just basically say var UI stats equals UI stats. Okay. And in this case, because I initialized, I passed in the empty string there, which there's probably a better way to do that. But because I initialized it, then even though it is a class, I'm not getting any, I don't have to actually put in my own initializer. If I had have left this just declared, then it would force me to add an initializer. All right, so we've got that. And with these UI stats, we probably want to pass this to some other class. So in this case, let's say our sprite kit view. That would be the one we'd probably want to do it. So I'm going to go to my sprite kit view, and I'm going to declare a variable. So UI stats, we'll say okay, so we've declared that. And in this case, okay, I did something wrong here. Okay, I have to declare as var, yeah. Okay, so yeah, I forgot. It's either let or var. Let if it's constant, var if I'm going to modify it. So in this case, I have UI stats. Now, I'm using a struct, and as we know with Swift, if you use a struct, it provides you a default, or automatically, it provides you an initializer, so you don't have to create your own. And so now when I go back to my content view, I'm going to have to pass in UI stats. And let's try running this. Oh, that does not. Okay, I have to add my label. So I'll just click fix. There we go. All right. So I've got my UI stats there. Actually, let's just keep going. So if I go back to my sprite kit view here, what I want to do then is make a modification to this data. That way I can then see it updated inside the view. So for that, I will go into my update interface object method here. And I will say UI stats dot objective equals collect wood, right? So that's going to match. That's basically the same one that I was passing in to my sprite kit scene. So if I go now into my sprite kit scene, I'm going to take this. Oh, it was repair radio tower. Okay. All right. So let's just remove the sprite kit scene node. So instead of, I'll comment out adding the task text node, and let's go back to my sprite kit view here, and I'll change that from collect wood to repair radio tower. And then the last thing I really need to do is go in and basically now modify my SwiftUI view so that it basically references the objective here. So instead of just putting in hello, I'm going to want to say UI stats dot objective. All right, so I've got that there. Everything looks pretty good, I think. Now, the one thing missing, though, is I've forgot my observed object property here. So I have to go at observed object. If I don't have that, even though the UI stats has properties and they will be signaling that they've changed, if I don't have observed object, then I won't be listening for those changes. So at this point, I can go run this. Okay, there we go. There we go. So I've got, obviously, there's a bit of work to be done here, but we've got the SwiftUI now rendering the UI, and we have the sprite kit doing the character animation. And the assets I'm going to give you to work on, I'm going to give you some really nice looking backgrounds and some really nice looking characters, and you'll then be able to render those using sprite kit, and we'll render the UI using SwiftUI. Okay. So just one other thing I was gonna, just mention. When I was planning this out, I really had three choices. I could have gone with what we had last year. Okay, I'm gonna stop the character. He's kind of distracting me. I could have gone with what we had last year, which was just use storyboard. And there's a lot of advantages to doing that. It would have been a bit simpler. It would have been easier to find information when you run into problems, because it's just been around a lot longer. So that was definitely one way I could have done it. The other one, though, I've considered was just to do the entire thing in SwiftUI. So no sprite kit. I mean, if you consider that SwiftUI can manipulate images, no problem, and this is a fairly simple game that we're going to make, that was a consideration. And it would have, I never really went, investigated that too far, but it is kind of an interesting thought how that would have turned out. But the one we went with, I'm excited to try out. I think it's kind of to keep learning SwiftUI. I think is a good goal, and I think this project will hopefully achieve that. Okay, so I'm gonna wrap things up there. What I want you guys to do is get on the Cloud Max. Let me know if you're able to log in, everything works. I will be posting a link to the new repository, and I will be posting links to the review tutorials that talk about the state and observed object properties and such. So I'd like you guys to look through that and go through, build the project and go through the steps I just showed you to basically modify the view so that it displays stats from the game. All right, that'll be it then.